Good evening, Manas. Good evening, Kanish. Good evening, Kritika. So only 3 students have joined. Acha, you people have joined before. Good evening, Himanshu. You never participate in the class, Himanshu. Who all have joined? Please write your name so that I should know how many of you have joined. I can see in the top chat there are 7 students, right? Okay. Good evening, Ayush. Good evening, Amisha. Good evening, Archika. Good evening, Aman Singh. Okay. So today we are going to start very important topic of this chapter. We'll be learning about indicators, and then we'll learn about how many types of indicators are available, like common acid base indicator, we know about that. Then we know about universal indicators. Then how with the help of these we are going to identify any acid or a base, right? And how we can identify strength of an acid or a base, how we can say that these are acidic or basic solution, because generally whenever we see any acidic solution or basic solution, they are colorless liquids. So if we need to identify whether it's acidic or basic, so how we can identify? Obviously with the help of acid base indicator. So there are lots of acid base indicator. There are color acid base indicator, there are olfactory acid base indicator, there are natural acid base indicator, there are synthetic acid base indicator. So we'll be studying today that, and then I will introduce you how we can prepare salts by using the different methods, right? And what kind of salts are available, right? So let's start, right? So if I show you this picture, what comes in your brain? If I show you this picture, what comes in your brain? And what is this color is representing? Can you identify? Shingarika, good evening. Can you identify which substance is this? You can see it's showing color changes. It's showing color changes. We can see the blue color is changing to red, and we can see it is a citrus fruit. All citrus fruits are acidic in nature due to the presence of citric acid, right? So how we can check the substances whether it's acidic or basic? Because we know there are 118 elements in the modern periodic table. Out of 92 elements are natural and 28 elements are man-made. But when these elements combine with each other, they can form 3 kind of substances: acidic, basic, acidic, basic, or some may be neutral, right? And they can also form salts, right? So that orange acidic in nature. Yes, Archika, citric acid. Manas has written the correct answer, citric acid. Because of the presence of citric acid, you can see this blue litmus is changing to red, right? So now what are acid base indicators? Whenever I say indicator, because when you have seen in the first slide, you have seen lots of test tubes were having with the different color, right? So these are actually, I am talking about right now, color acid base indicator. As I told you, what is our objective? Why we need acid base indicators? Because acids or bases substances both are colorless liquids, and if we need to identify whether substance is acidic or basic, we should have acid base indicator. So whenever we say indicators, indicator represent a dye actually, right? So and indicators are weak organic acids, you can say. These are the weak organic acids and organic compounds, not acidic. It can be acidic or it can be basic also, which can change their color due to the presence of, they can change their color in the acidic or basic solution. It means indicator is a dye which changes their color in the acidic or basic solution, right? What is the reason behind that? Why they are changing their color? We know that acids are proton donors and bases are proton acceptor. So when indicator get a proton, then they change different color. When they don't get any kind of proton, then they shows different color, right? So the most common acid base indicators are the complex molecule, and that's why I said they are organic in nature. Most of the acid base indicators, they are weak organic compound. They can be acidic in nature, they can be basic in nature, right? And then indicator dissociates slightly in solution, producing ions and undissociated molecule, and that's why they are the weak organic compound, right? So the color of the ion produced dependent on the hydrogen ion concentration or the pH of the medium. If they get the pH more than 7, then obviously they are going to show different color, and if you find that pH is less than 7, they are going to show different color, right? So the most common acid base indicators are the complex molecule that are themselves weak acids, or sometimes they are basic in nature also. So they exhibit one color when they are in a neutral form, right? They exhibit only one color when they are a neutral form. Suppose if it is red litmus, litmus will remain red in the neutral solution, and blue litmus will remain blue in the litmus solution, the neutral solution, right? And likewise phenolphthalein will remain colorless in the neutral solution. Methyl orange will orange in the neutral form. They can show only one color, right? And when they are exposed to any acidic solution or basic solution, they exhibit one color when the proton is attached to the molecule, another color when the proton is absent. So in the basis of H plus ions, if the H plus ions are present, right, why they are changing their color? It is because of the presence of H plus ion. Why the color of the ions produced in that? Because they are dependent on the hydrogen ion concentration, or you can say the pH of the medium, right? And if they get H plus ion, they are going to show one color. If they don't get, they are going to show another color. Okay, so indicators are commonly used for the titration to mark the end point of the titration for the complete neutralization reaction. We'll be studying that also. Sometime, if you remember, when I have discussed the monoacidic base combined with the dibasic acid, in that case there will be no complete neutralization. So how we'll identify how much quantity is required? So in that case, we'll be using indicator, and we'll keep on adding that acid with the help of the titration setup. So what is going to happen? There was one end point will come where when you have to stop adding acid, in that case the color of the indicator will disappear. Suppose if you are using phenolphthalein, and if you add to any basic solution, they will turn to pink. But if you keep on adding acidic, this pink color light will disappear, right? This pink color is going to disappear at the end point of the titration, where you will see the colorless solution is there. It means pink color disappear. It means the complete neutralization reaction has taken place, right? The end point should be very close to the equivalence point to reduce the error, right? So you can see there are various acid base indicators, right? There are various. Can you name few acid base indicators? Can you name few acid base indicator which is generally available in the lab? Yes, class. Can you name some? You can see on the screen also now. You can see that red cabbage water. Red cabbage is a natural acid base indicator. You must have seen sometime we go to the visit to restaurant, they give us the red onion, right? Because they are changing their color, right? And it is also sometimes it also categorizes as this thing olfactory acid base indicator, because onion is a olfactory acid base indicator, because when it is present in the acidic solution, when you treat one cloth with the onion and keep it in the acidic solution, you can detect the smell of the onion in that particular cloth. But when you same cloth which was treated with the onion strips, and if you dip in the basic solution, you will not get any kind of smell. It means you will not be able to identify characteristic smell of onion in the presence of basic solution, but you will be able to identify its smell in the presence of acidic solution. And this is the same result can be seen with other olfactory acid base indicator. Right now we are discussing color acid base indicator, Right now we are discussing color acid base indicator, where you can see red cabbage. So if pH is less than 7, it can show the red or pink color, and if pH is equal to 7, it is going to show purple color, and if pH is more than 7, it can show blue, green, yellow color, right? And if you have red onion, water, red means it is, if pH is less than 7, it will show red color. If it is pH equal to 7, it is going to show violet color, and if the pH is more than 7, it is going to show green color, right? Then turmeric is also natural acid base indicator. You must have seen whenever we have a food curry spot in the white cloth, we get yellow spot over there, and when you rub with the soap, it becomes reddish brown, because soap is basic in nature. Okay, so it will remain yellow at pH equal to 7 or less than 7, but it will change to reddish brown if pH is more than 7. So it is also a natural acid base indicator, right? Understood, Shingarika, Kritika, Kanish? Okay, so when you see phenolphthalein, I told you in the beginning, phenolphthalein is a colorless liquid. Phenolphthalein is colorless liquid, right? And it can show it pink or red color, depends upon the which pH value. It sometimes with the lesser pH, it is closer to the 7, 7.8 or 8 or 9, so it is going to show pink color. When pH will go beyond, it is going to show red color. So it can show pink color or red color also, right? So what about the bromothymol blue? It is yellow in the acidic solution, or maybe pH less than 7, and it will be green in color. Yes, understood. So it will be green in color in the presence of pH neutral solution, or you can say the if pH equal to 7, right? And if pH is more than 7, it will show its color, that is blue color. Okay, and then red litmus, we know that red litmus will remain red in the acidic solution as well as the neutral solution. Understood? Then and it will change to blue in the color in the presence of basic solution. It means if pH is more than 7, right? And if I say blue litmus, so blue litmus will changes to red in acidic solution. It will remain blue in case of pH equal to 7, and it will remain blue in case of pH more than 7, right? So in the neutral form, the blue color can be seen. It means pH equal to 7. If pH is more than 7, once again the blue color can be seen with the blue litmus. But sometimes we don't know the strength of the acid, because these cannot help us to these indicators can help us only to get one information, whether substance is acidic in nature or basic in nature, right? So how to find out strength of the acid, right? Because we know the lesser the pH value, the stronger the acid will be. All strong acid will have lesser pH value, right? And all strong bases will have higher pH value. But how to identify the accurate pH value? There are some, in some industries where medicines are produced, they have a pH sensor. They touch the substance, they get to know about the pH. They have pH sensors, right? And but in the lab, how we check the substances? With the help of universal indicators. So universal indicator have here you can see only one kind of indicator is present. In acid base indicator, only one kind of substance is present. If they get proton, they show different color. If they don't get proton, they don't show that, they show the different color, right? It means if you want to find out whether substance is highly strong acid or a weak acid, or you can say the strong base or a weak base or neutral, so how to know about the strength of acid? So we can know about the strength of acid or a base with the help of universal indicator. Here there is only one indicator, but universal indicator is a mixture of what? So we know that litmus is used to show if a solution is acid or alkali. Litmus does not show if the acid or alkali is a weak or strong. For that we require a indicator which can give us a complete, a very wide range of the color. So universal indicator is a mixture of different indicators. It can give different colors at different pH values. So every time it is going to show different color at different pH values, right? So we can say the universal indicator has a range of color that show how weak or strong the acid or alkali is, right? The strong acid will always go which side? Towards the red side. What is the color of the weak acid? We can see the color of the weak acid. The color of the weak acid is yellowish, right? Here you can see the strong acid has a dark color. When you go to the alkali side, weak alkali side, the light purple, light blue color. But when you go to the strong alkali, you can see the dark violet color, right? Understood? So now what is actually, in which form we can use? We can use either in the form of pH paper, or we can use in the form of universal indicator solution. So generally in the lab pH paper is kept with the help. It is very easy to test with the help of pH paper. Understood, class? So what is pH paper actually? It is a strip of fine filter paper impregnated with the universal indicator. It means there is a mixture of you can say the different indicators, and they are treated with the fine filter paper. Now the filter paper is having this mixture of different indicators. Obviously at different pH value it is going to show different color, right? I told you, if you find 0 to 3 pH value, then it will be a strong acid and the dark red color can be seen. If it is a weak acid, it means pH 3 to 6 and it is acidic, but it is a weak acid, and orange and yellowish color can be seen. But if it is a neutral, the green color can be seen, right? If pH is ranging from 8 to 11, it means it is a weak base and the blue color can be seen, right? And if the pH ranges from 11 to 14, so obviously this given substance is a strong base, and the color what color we can see on the pH paper when it is treated with the strong base? Violet or purple color, right? Understood? So what is a universal indicator? Universal indicator is a mixture of several indicators and it shows different colors at different pH paper. It gives only the rough idea to measure the exact pH value. Now for that the pH meter is used, and with the help of the pH color chart. Sometimes we use the pH sensor, sometimes we are using pH paper, and then we match the color of the pH paper with the pH color chart. And if it matches the same color, if suppose it is a dark red color and comes on the pH paper, it means the pH value of that particular substance is 0. And if you can see the light green color, then the pH value will be 4, suppose, right? If there is a light yellow color, then pH will be 8. If the green color, it means the given substance is neutral. So different colors you can see, it ranges from the pH paper ranges from how much color from it, how much pH range is there, 0 to 14, right? Now you can see different substances have different pH value. You can see in the battery which acid there is a strong H2SO4 is there, and that will have pH equal to 0. And then the stomach we have HCl. In the stomach which acid is present? HCl, and that has a pH value equal to 1, right? In the lemon, has a citric acid and its pH ranges from 2.8 to 3.1, right? And then we have a soda. All soda contain carbonic acid, and carbonic acid will have a pH ranging from 3.9 to 4, right? And then we know in the tomatoes, organic acid is the oxalic acid is there, and then pH will be 4.5, right? The milk has pH 6.6 or 6.9 something, right? And that's why if the pH will drop due to the high temperature, it will become sour in taste, and because of the presence of lactic acid. And the water which we drink, we know that has a pH equal to 7. Understood, class? Understood? Likewise, there are other substances which are showing the different pH. So let's read from your book also. So let's read from your book also. The term indicator we have already understood. The indicators are weak organic compound which change their color in accordance to the pH of the solution. Every time the color change depends upon the pH of that particular substance. Understood? And which change color in accordance to pH, we know that. Now indicators dissociate slightly in the solution, producing ions and undissociated molecules. If H plus ions are going to attach, obviously they are going to show the different color. If it does, H plus ions are absent, it means proton is absent, then they are going to show different color. And we can say the color of the ion produced in the dependent is dependent on what? Hydrogen ion concentration, or you can say the pH of the medium. Now just now we have seen that the pure water has pH equal to 7, right? It means what will be the concentration of H plus ion and OH minus? They are equal in number, that's why they are neutral. Water is a neutral. Why? Because water contain equal number of H plus ion and hydroxide ion, so they cancel the effect of each other, right? Because both contain how much what is a pH value, or how much concentration H plus ions are there? 10 to the power minus 7 mole per decimeter cube at room temperature, right? Thus the product of two ionic concentration will be 10 to the power minus 9, because H plus ion concentration is 10 to the power minus 7 and the pOH is also 10 to the power minus 7. So since both are equal in number, and the Kw of the ionic product of water will be 10 to the power minus 14, and since they are equal in number, so they cancel the effect of each other and the substance will become neutral, because H plus ions are responsible for giving acidic behavior and hydroxide ions are responsible for giving basic behavior, right? So when an acid is added to a aqueous medium, the H plus ion concentration increases to above 10 to the power minus 7, and at the same time if the basic substance and the hydroxide ion concentration decreases to below 10 to the power minus 7, in that case the substance will show the pH value, it means less than 7, right? And if, on the other hand, if any basic substance is added to water, so obviously the OH ion concentration is going to increase and the pH will go beyond 10 to the power minus beyond 7, right? So the pH value represent what? The pH value of any substance represent the strength of the acid or alkali, and it is always expressed in the hydrogen ion concentration. I told you pH 7 means neutral. H plus ion and hydroxide ion both are equal. If the pH is less than 7, in that case hydrogen ion concentration is more than the hydroxide ion concentration. Yes class? And if pH is more than 7, so obviously the substance is basic in nature and the hydroxide ion will be more than the H plus ions. Understood? So how we can determine the pH? By using this, we can see 10 to the power minus 1, 10 to the minus 2 means if their concentration is 10 to the minus 1, it means pH value will be equal, right? If 10 to the power minus 2, it means the pH value will be 2. If the concentration of hydrogen ion is 10 to the power minus 3, then the pH value will be 3, right? If the concentration of the hydrogen ion is 10 to the power minus 5 mole per decimeter cube, then the pH value will be 5. Likewise it will keep on going. So what we will observe, when you move from left to right, hydrogen ion concentration decreases and the substance will become more alkaline in nature. pOH means power of hydroxide ion concentration is going to increase, right, and the power of hydrogen ion concentration going to decrease. But when you move from right to left, in that case the hydrogen ion concentration is going to increase. In that case substance will be acidic in nature. Understood? Okay, so just now we have already discussed about the common acid base indicator, that is litmus, methyl blue, phenolphthalein. These are the common acid base indicator, and where we use, we just want to find out whether given substance is acidic or basic. How many students are watching? Okay, Shingarika, Anushka, Kanishk, Archika, Manas, understood, not understood? Understood or not understood? Yes class? Shingarika, Manas, Kritika. So we know that what is the utility of common acid base indicator. We have to find out whether given solution is alkaline or acidic, and it cannot be utilized for strength, determining the strength of the acid or a base, right? And it cannot differentiate between the acidic or basic solution of the different pH value, since they change their colors abruptly at certain pH value, right? So you, on the basis of same color, you can't identify, right? But if you are using universal indicator, you will come to know exact pH value of the particular substance, and then you can easily find out the strength of the acid or a base, because we can easily we can utilize to determine the strength of the acid or basic solution in the presence of universal indicator, but we cannot determine the strength of the acidic or basic solution in the presence of or acid base indicator. So if you exactly want to find out what is the strength of the given substance, or definitely will be using a universal indicator. You can see both are colorless solution, and how to find out the given substance is acidic or basic. You can see we were using the blue litmus. When you dip inside, you can see the color has changed from blue to red. It means the given solution is acidic, right? And likewise, when you touch the red litmus, you can see after dipping this, it has changed to blue. It means the given solution is alkaline in nature. It means the given substance is basic in nature. So this can give only one information, that they are acid or base, but they cannot give us the information regarding, right? So we have already discussed this color changes. I don't think so you will be finding any difficulty. And then what are the uses of why we require acid base indicators? Why we require indicators? Because in agriculture, the pH of the soil is tested for the better growth of the crop or citrus fruit nearly slightly alkaline soil, because they themselves are acidic in nature. So they need slightly alkaline soil. Rice require acidic medium, sugarcane require a neutral medium. So every time farmer need to check the pH of the soil in order to find out the exact pH value of the soil, so that plant can grow well. If you want a good yield of the plants, you need to check the pH of the soil, so that if the soil is found to be acidic and the plant can grow well in the neutral, you need to add something, a basic substance in that. Suppose if you find that the soil is basic in nature and the substance can grow well, the crop can grow well in the acidic medium, so in that case you need to add something acidic in that, right? So that the pH should be of the soil should be acidic. And sometime if you find whether it is acidic or basic, you need to add something in that. Suppose you find something acidic, soil is acidic in nature, you need to add something basic. If soil is basic in nature, you add to need this, because every time neutralization reaction is going to take place, because we know that when acid combine with the base, they form salt and water. The dairies, they need to check the pH, because if they are using they have to distribute milk, and the pH of the milk goes down, the whole pH will turn to what? Sour in taste, right? So at pH 6.6 indicate the milk has turned sour, right? And the technology, biochemical organic reaction, they carried out under specific control pH. We know that if the pH is going to change, no chemical reactions are going to take place, since the medicine manufacturers, they have to take care of that, right? They have to take, because with the help of pH values of the urine and blood, right, they can diagnose various diseases. When they find that if the pH of the urine or blood has increased or decreased, so this shows the person is suffering from some kind of trouble or diseases, so they can easily find out the ways to treat that particular disease. So various disease can be diagnosed on the basis of what? The pH value of the urine and blood. Understood? Okay, so we have already understood the pH. pH is a measure of how acidic or basic solution is. The pH scale ranges from 0 to 14, right? Acidic solution always have pH equal to below 7, and the solution with the pH 0 is very acidic, and solution with pH 7 is neutral. pure water has a pH of 7 and the basic solution have pH value above 7. We know that, we have done this. Okay, so a change in the 1 pH unit represent how much? 10-fold. It doesn't mean if the pH change, the substance is changing from 1 pH to 2, so there is no bigs, but it is going to change into 10-fold, and that's what 10 to the power minus 1, 10 to the power minus 2, there is a large difference. Every time it will keep on increasing 10-fold, right? So if I say the pH change, a change of 1 pH unit represent a 10-fold change in the acidity of the solution. For example, if solution has a pH equal to 1 and the second solution has pH equal to 2, the first solution is not twice as acidic that second, it is 10 times more acidic, right? It is 10 times more. It's not only 1 point is going to increase, it will be increased to the 10-fold, right? So there is a large difference between one pH to another, right? And if suppose pH 1 and pH 3, so multiplied by 100 times, 100-fold, it is going to increase to 100-fold, right? If you compare pH 4 to pH 1, pH 4 and pH 1, obviously pH 1 will be how many times? 1000 times more acidic than the pH value at 4. So there is a large difference. If there is a pH change, it is always multiplied by 10. Understood? So now very important thing, how we can prepare salts, right? Very important thing, how we can prepare salt. We know that when acid and base combine with each other, neutralization reaction is going to take place, right? So when acid base combine with each other, they mix together and they are going to form the neutral solution, right? Now suppose if you have taken pH, the base which has a pH equal to 12, and you have substance, acidic substance which has pH equal to 2, if you mix them together, you will get a substance which will have a pH equal to 8. It means that what will be the nature of this salt which will be produced during this reaction? Obviously the pH will be 8. It means it is more than 7. The substance will be basic in nature, right? So acid base mixture is not acidic or basic as individual starting solution, but when you mix them together, they are going to form some acidic substances, some basic, and sometimes you get a every time when any acid and base combines together, we get salt and water. So we can say the who are the parent of the salt? The parent of the salt are acid and base both, right? So generally what happens, whenever you see any salt, the first name is always comes from the base. The first name is always comes from the base. Suppose if I say sodium hydroxide is combining with the sulfuric acid, and the salt which we'll get will be NaHSO4, means sodium hydrogen sulfate. The sodium name comes from the base and the sulfate comes from what? Acid. So we can see the first part of the salt is basic radical, and the second part of the salt, which is a negative part, is a what? Acid radical, right? So it means salt always contain one acid radical and one basic radical. The first part is always a basic radical because this comes from the base. So Na comes from base and HSO4 comes from the acid, and this is the acid radical, right? So a salt is a compound formed by either partial or the complete replacement of the replaceable ionizable hydrogen ion. If it is there, you can see in this case, we have already discussed this case. If it is monoacidic base combining with a dibasic acid, we get acidic salt. Why? Because there is a partial replacement. Still there is a one hydrogen atom which has not been replaced. So it has to, if there you want a complete neutralization of sulfuric acid, what we require? We require 2 NaOH. So if you take 2 hydroxide ion which can neutralize the 1 molecule of sulfuric acid, right? So it means you need to, if it is a monoacidic base, you need to take an excess, then only the complete neutralization will take place. Then salt which we will get with after that will be what kind of salt? That salt will be neutral salt. So because neutral salt can be prepared by the complete replacement of hydrogen, and then the acidic salt can be prepared by partial replacement. they are always ionic in nature. Why ionic in nature? Because we know that the ionic compound always have cation and an ion. So a salt is an ionic compound which dissociate to yield a positive ion other than hydrogen ion concentration. We know that hydrogen ion is a positive and hydroxide ion is a negative ion, right? So when you take an aqueous solution of any compound, they are going to give us one cation and an ion. For example, if you are taking sodium chloride and when you are going to dissolve this in water, so what is going to happen? We get sodium ion and chloride ion. It means salt will always have cation and an ion, and they are always a ionic compound. Salt will always a ionic compound, right? So salt can always prepare when an acid and a base combine together with each other. They are going to form water and salt, and then salts are always ionic compound, we have understood. But some salts can be acidic in nature, some salts can be basic in nature, some salt can be neutral. But how we can find out? Suppose if you are taking strong acid and a strong base, when they combine, the salt which we will get will be neutral. We are going to get a neutral salt, right? And if you are using strong acid and a weak base, the salt which we will get will be acidic in nature and the pH will be less than 7. But when you are taking a weak acid and a strong base, you will get a basic salt and the pH will be more than 7. Strong acid, strong base, neutral salt, the pH will be equal to 7. Strong acid, weak base, you will get acidic salt and the pH will be less than 7. And weak acid and a strong base, when combined, it is going to give us basic substance, and the substance will have pH more than 7 because it is basic in nature. But if we are using weak acid and weak base, you will get neutral salt. So you know all the condition, you can get a strong, because there is a probability you can take either strong or a weak base, or strong acid or a weak base. When they combine with each other, what kind of substances? Suppose this kind of salt, for example, if you are using a strong acid HCl H2SO4 and you are using strong base, that is NaOH and KOH, the salt which you get by this, you will get NaCl, and with the KOH and H2SO4 you get K2SO4. Their pH will be equal to 7 because these are normal salt, you can say the neutral salt. But if you are using a strong acid, that is HCl or nitric acid HNO3, but you are using weak bases means ammonium hydroxide and magnesium hydroxide, the salt which you will get will be known as acidic salt, and the pH will be less than 7. Likewise, you can see the sodium carbonate can be prepared from the weak acid and the strong base, and the sodium carbonate will be formed, right? So this is what these are you can see the basic salts, and they can be prepared with the help of what? Weak acid and strong base, and the pH will be equal to in that case basic substance pH will be more than 7, right? Now when you see acid salt law, let's read from your book also what your book says. Shingarika, you are not responding. Archika not responding. What happened, Shingarika? Kanishk? Yes, Kanishk. Shingarika? Okay. So types or classification of the salts, right? We know that there could be acidic salt and the normal salt. The salt formed by the partial replacement of, means you are using a insufficient amount of sodium hydroxide and you are using a dibasic acid. In that case you are going to get acidic salt, right? Even if you are using sulfurous acid, then also you will get an acidic salt. So only one H plus ion in the sulfuric acid or sulfurous acid is replaced by the metallic radical, that is sodium, which is present in the base, right? And then you will get this kind of salt, that is acidic salt, and the pH will be always less than 7. Okay, but if you are using a normal salt, if you want to prepare a normal salt, the normal salt can be prepared with the help of sodium hydroxide. If you have to take this in the Icse and sulfuric acid, understood? And if you are taking in the both the cases, both hydrogen atoms are going to replace and by the metallic atom. So what is going to happen, the salt which we will get will be normal salt and the pH will be equal to 7. Okay, so we can learn some example. If it is a salt of nitric acid in that you please remember one thing, if it is monobasic acids they will always form a normal salt. Please remember, if it is monobasic acid, since they can give only one H plus ions, so they can always form normal salt. So in case of HNO3, HCl, CH3COH or HCOH, in these cases you will get normal salt because there is no hydrogen ion will be left behind unreplaceable, so they can form only normal salt. The second, if you are taking dibasic acid or tribasic acids, in that case you will get acidic salt. It means carbonic acid can give acidic salt, sulfurous acid can give acidic salt, sulfuric acid can give acidic salt, phosphoric acid can give, and phosphoric acid to can give two types of disodium hydrogen phosphate, right, dihydrogen sodium phosphate, right, understood. So it can give two types of, depends because it is going to ionize into 3 steps and every time it is going to give acidic salt, at the end it is going to give the normal salt. So phosphoric acid can give 2 acid salt and 1 normal salt, right. And if you are using this nitric acid, obviously it is always give us normal salt. If HNO3 can give sodium nitrate or can give calcium nitrate, these whatever salts are going to produce with this will be always normal salt. HCl means NaCl is a normal salt, then CH3COH is a normal salt, the sodium carbonate is a basic. Now here that funda will come, whether what will be the pH. pH depends upon whether they are strong acid and a weak strong acid and weak base is going to combine. Obviously the salt which will get will be acidic in nature. Understood? So this to we have understood. Now how many types of methods are there? Next class will be doing this. I will give you just introduction and then I am going to end my class here. So you can see here how salts can be prepared. There are so many methods. There are 6 methods you can see. We can see with the help of direct combination reaction also, metal and non-metal when they combine they form salt, right. For example, Na plus Cl or iron plus Cl2 or aluminium plus Cl2 or iron plus sulfur or zinc plus sulfur or lead from sulfur. Every time when any metal combine with a non-metal, the salt we can get 2 types of salt, whether it can be soluble, it can be insoluble also. We should always remember one thing, when we are getting any sodium salt or ammonium salt or potassium salt, these salts are always soluble salt. You have to remember one thing, they can always produce soluble salt, but if some other elements are there, other metals are there, they can produce different insoluble salt. But if it is potassium salt, sodium salt, it means we can say all sodium salt, all potassium salt, all ammonium salt will be soluble salts, right. And we just now we have discussed, if any metal non-metal combine with each other, they can form either soluble salt and insoluble salt. It means both kind of salts can be produced. You can see in this example also, if you see the direct combination reaction, you can see in iron when combined with the chlorine it is going to form ferric chloride, and ferric chloride is always soluble, and likewise aluminum chloride is always soluble. But if you see the lead iron sulfide or a zinc sulfide or lead sulfide, they are always insoluble. When iron is going to combine with sulfur or zinc is going to combine with the sulfur or lead is going to combine with sulfur, they will always form insoluble salt. So we can see during the direct combination reaction, when metal combine with the non-metal, they can form either soluble salt or insoluble salts, right. We can see one example. Salt composed of 2 simple ions such as a metal chloride can be prepared by reacting 2 elements, a metal and a non-metal, right. And the metal supplies the cation and non-metal supplies anion, we know that aluminium chloride can be prepared by the help of direct combination reaction, but aluminium chloride will be soluble salt. On the other hand, when you see the lead with warming with the sulfur, when you heat lead with the sulfur or iron with the sulfur or zinc with the sulfur, you get metallic sulfides, and metallic sulfides are insoluble. It means during the direct combination reaction we can get soluble salt as well as insoluble salt. Understood? So in the next class we will be continuing. I am going to end my class here. Thank you very much. God bless you all, beta. Thank you.